Assalamualaikum. Our group will present about wind power generation, and I will start with introduction. Wind power generation means getting the electrical energy by converting wind energy into rotating energy of the blades and converting that rotating energy into electrical energy by the generator. So, wind power generation consists of wind turbines that converts the kinetic energy present in the wind and is convert into mechanical energy by means producing torque. So this is the part of turbines that consists the main components such as blades, generator, and pitch control. There is also wind turbines transformers that act as a link between wind turbines and distribution grids. It steps up the low output voltage from the generator to higher distribution voltage level. Wind power generation is a good way to produce electrical energy because wind is safe energy source existing everywhere and there is no need to worry about depletion like fossil fuel. It also uses simple equipment and handling with easy operation. Other than that, this way also can fuel efficient to nature environment as there is no carbon dioxide emission.
Now we are going to discuss the basic principle and operation of wind power. As we can using electricity to make the wind, we can also use the wind to produce the electricity by using wind turbines, and this process called wind power. As we see in this shape, we have wind power has a kinetic energy. It's around us in nature. When the wind collides to the wind turbines, the kinetic energy will convert to mechanical energy. That's the energy of rotation of the blades. When the blades started rotating, the electrical energy the mechanical energy will convert to electrical energy, which because the blades connected to the rotors, which control the blade axis, and the rotors also connected to the generator, which produce the electricity. The combination of the wind and the airflow caused the rotation of the rotor near the blade rod. The radial velocity of the blade is low while on the tip of the blade, so the tip of the blade is twisted into the direction of the airflow to ensure the right angle of attack to harvest as much energy from the wind. We have to turn the wind turbine blades at a very low rate to avoid the noise issue and mechanical stress, but this will make the generation of electricity will be too few. So we have to set up the planetary gearbox to achieve the maximum speed and increase the speed of the generator to generate more electricity. And also we have the brake system, which control the turbines and save it from crashing in windy days when the airflow will be too strong. Electricity produced from the generator passes through a cable towards the bottom of the tower and is stepped up by the transformer at the bottom of the tower. We have also a wind vane and anemometer, which located on the top of the seal, which used to measure the wind speed and direction. And the control system controls the mechanism to rotate the seal with the help of the we have to check the efficiency of the wind turbine. We can measure the wind speed at upstream, which are on the rotor, and downstream over wind turbine. The wind speed of downstream is much slower than on the upstream. So Vn or V upstream always greater than V out. And we can see here in Pitt's law. Pitt's law can show or indicate the maximum power that can extract from the wind. According to Pitt's law, no turbine can capture more than 16/27, approximately 59.3% of kinetic energy in wind. So if we want to prove that this theorem, we have the velocity, or we have two speeds, the speeds upstream and the speeds downstream. So we have to take the average velocity, and the mass we have the speed difference between the twisting force and the average velocity. When we apply Newton's second law, we will get this equation, and after substitution in the mass, we'll get this equation for P total power. And to get the initial power P naught, we can cancel out the V2 and we will take this equation. And the ratio between P total and P naught will be this last equation.
Hello, my name is Muhammad Syamil Iman and I'm gonna present about basic construction of wind power generation. First, a tower. A steel tubular tower with an inner ladder leading to a nacelle or a steel lattice tower roughly comparable to an electrical tower. These are the examples of tower: tubular steel tower, lattice tower, guide tower, and hybrid tower. Next, nacelle. It contains all the components of a wind turbine that is housed for all the components, for example an electrical generator, power converter, gearbox, turbine controller, cables, a yaw drive. This is the picture of nacelle. Then a rotor and a rotor blades. Blades are the main mechanical parts of wind turbine. The blades convert wind energy into usable mechanical energy. The rotor blades are primarily made of reinforced carbon fiber plastics or glass fiber. Then, shaft of wind turbine. The shaft directly connected to the hub is a low-speed shaft. When the blades rotate, this shaft spins with the same RPM as the rotating hub. Next, gearbox and generator. A gearbox is used in wind turbine to increase the rotational speed from a low-speed main shaft to a high-speed shaft connecting with an electrical generator. The generator is an electrical device that converts mechanical energy received from the shaft into electrical energy. These are the gearbox and the generator of the wind turbine. Next, power converter. Because of the wind is not always constant, so the electrical potential generated from a generator is not constant. But we need a very stable voltage to feed the grid. A power converter is an electrical device that stabilizes the alternating output voltage transferred to the grid. These are the power converter.
The example of wind turbine generation site. First, in UTeM Wind Power Base, China, also known as Gansu Wind Farm. It installed capacity of 20 GW, it featuring 7,000 wind turbines, capable of producing energy to power a small country. Installed across Yunnan, Inner Mongolia, Hebei, Xinjiang, Jiangsu and Shandong provinces of Gansu, China. The next one is Jaisalmer Wind Park in India. It is the biggest wind farm in India, located in Jaisalmer district of Rajasthan, India. It can produce 1,600 MW of power. And the next one is Alta Wind Energy Center in US. It can produce 1,548 MW of power, located at Tehachapi in Kern County. The wind farm spread across 3,200 acres. The characteristic of good wind power. First is it must be placed with high average wind power speed. Typically, the site will be on top of a hill or in a wide open space with no obstruction nearby. Second one is it must be separate from home site. Modern wind turbines are remarkably quiet, but even so, there are very stringent maximum noise level that have to be met. The third one is it must have a good grid connection. Some wind turbines require a suitable three-phase electrical supply to connect to. And the fourth one is it must have a good site access. Wind turbines are large and heavy, so the access roads and tracks to the site need to be capable of taking oversized loads with no weak bridges, excessively tight corners, or steep gradient. And the last one is no special environmental or landscape designation. A lot of objection to wind turbines due to bird strike, so it will be good practice to not install a wind turbine in an area that had special bird designation.
Hi, my name is Ko Hao Yik. My metric number is B012110077. For my part is interesting and attractive. Wind energy was first developed in windmills in 200 BC in Persia and China. Wind energy was then used for hundreds of years to pump water and crush grain. People also use sails on sailboat as a form of wind power. Turbine tower normally stand over 328 feet tall. That is taller than the Statue of Liberty. Each turbine blade is normally 260 feet long. The largest turbine crate is in Hawaii. It is 20 stories tall and each blade is the length of a football field. Wind energy is the only form of alternative energy that does not require water. Turbines are getting taller to reach faster, more constant wind, higher in the atmosphere. The higher you go, the faster the wind, and the more energy that can be produced. Wind energy accounts for more than a third of all newly installed US electric generator. One small turbine in your backyard could power your home. In 2014, enough wind energy was produced to power more than 17.5 US homes annually. That is every home in Alaska, California, Delaware, DC, North Dakota, Rhode Island, South Dakota, and Vermont combined. And then global investment in renewable energy capacity has soared over the past 10 years, as wind has emerged as cost-effective power source. Next, the green case for wind farm is clean. They produce electricity in a clean way, emitting no polluting gases to the atmosphere.